Okay, we're going to take a look at chemistry, Unit 1, concept number 1. So, just to kind of remind ourselves of how we get here, uh, if you start on Discovery Education, you would click onto your green button there, the Science Tech book. Your site might look a little bit different there. You would make sure that you clicked the chemistry book. You guys are familiar with this. There's drop down arrows, and you have 3 different textbooks. So you want to make sure you're in the chemistry book. And if we take a look at Unit 1, we can see that there are 6 concepts. 1, 2, 3, 4, 5, and 6, all underneath Unit 1. So we're going to take a look at the first one under Unit 1. That's concept 1.1, and it's called heat. So we'll click on that. And we want to jump right into our explores. There's 7 explore pages. These are like the pages in your textbook. So what I want you to do is I want you to go ahead and write these notes. These are written in the style of Cornell notes, and I'm going to go ahead and write down underneath here, Discovery Education, Chemistry 1.1. So this just tells me this is where the notes are coming from. Go ahead and put the date in the top left corner, and where it says EQ, this is your essential question. Go ahead and write down what is heat. Okay, and that's coming directly from your text. What is heat? You can see there, I'd highlighted that. Okay. And a good way to engage with your notes is to start by saying what you already know. You may want to do that. You may know a little bit, you may know a little bit or a whole lot. So go ahead and just write down what you know about heat. Okay. After you're finished writing that, we're going to be following the text, and we're going to take this text and put it into note form. Okay. So heat. What is heat? Heat is the transfer. Remember, transfer is the same as saying the movement, the transportation, right? Heat is the transfer of thermal energy from high temperature objects to low temperature objects that are in thermal contact. If you're touching a hot pot of water, it's hotter than your hand, you're going to feel the flow of that energy from the hot pot into your hand, and it's going to feel like a burn. Okay, so in spontaneous processes, spontaneous are things that happen with little energy input. They have enough energy to make it happen on their own. In a spontaneous process, heat always flows from hot to cold. So that's what we drew here in our picture. You have object A is hot and object B is cold. We'd say that the hot object has more thermal energy. That's to say that the kinetic energy, the molecules moving in the object, there's more movement in object A compared to object B. So the energy is going to flow from A to B until what? Until A and B are equal to each other, and that's called thermal equilibrium. Okay? Thermal equilibrium. If we continue moving down here, they talk about the spontaneous process. We discussed that. Roman numeral 2, we're going to talk about the law of conservation and heat. I just want to make a note before we jump into this law of conservation in here. Let's just come back to this paragraph. And let's just take a look at this highlight. There is no physical process in which thermal energy is transferred from a lower temperature object to a higher temperature object unless outside influences such as work or force, outside influences such as work force it to do so. So could you make energy flow from a low temperature object to a high? You could, but that would not be spontaneous. That would not happen naturally on its own. It would require us to put some kind of additional force to make this happen. Okay. All right. So the law of conservation, as it relates to heat, this law applies to isolated systems. If you have a thermos and it's a well-insulated thermal cup with a tight lid on it, nothing can be exchanged with the outside environment. We might call that an isolated system. Um, it is closed off from the surroundings. So this law of conservation applies to um, isolated systems. Okay. In the context of heat, a system may gain or lose thermal energy, but the system's total energy is constant. If inside your thermos or in your isolated system, you have object A is hot and object B is cold, um, the total energy is the hot object plus the cold object, right? That's going to give you your total. Well, if energy flows from the first object into the second object, and now they're both equal in temperature, what's going to be the total energy in the system? It's still going to be equal, right? A has lost some energy, but B has gained that energy. Has there been a total change, a what we call a net change in the energy of the system? Nope, you still have the same amount of energy. It's just been spread out equally between the two objects. Okay, so that's kind of what this is speaking to. And as you recall, the law of conservation states that energy, and matter can neither be created or destroyed, but it can be transformed. It can be changed to a different form of energy, or it can be transported somewhere else. All right. Well, I hope that was helpful. In your Cornell notes, you want to write yourself a summary sentence or a summary paragraph in your own words, just kind of restating what you learned. I hope that was helpful, and we'll talk to you soon.